what you need to do is you need to get a common base. So for example, if I said 4 to the x equals 4 to the 5th, well, it should make sense that, oh, well, x must be 5. Okay, because 4 to the 5th is some big number, and if this is equal to that, then the x must be 5. So our goal is, when we're solving these functions, is to get a common base. If we can get the bases to be the same, then all we have to do is look at the exponents to solve that. So let's look at this example here. We have 2 to 3x and 4 to the x minus 1. So you do need to know your perfect squares. You do need to know that, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, you should be able to break those down. And I've said before, cubes will be helpful too. You should know that 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed, 6 cubed, and up to 7 cubed even. Okay, so you should know those because you're going to see those a lot. So you should know 5 cubed, 6 cubed, and 7 cubed. And we'll kind of get into that. So since this base is 2 and this base is 4, they're not the same. So we have to make them the same. So what we can need to do is we can rewrite 4 as 2 squared. So we have 2 to the 3x equals 4. I'm going to rewrite as 2 squared, but then I have that x minus 1 still on the outside. Now we're going to do our rules of exponents. Okay, when you raise a power to a power, you multiply. So I'm going to have 2 to the 3x equals 2 to the 2x minus 1. And distribute that, we multiply. Now we can apply this rule. Since the bases are the same, the exponents must have to be the same.
Wouldn't it be 2x minus 2?
Well, sure. In real math world, that's what it would be. Yes, thank you. Since the bases are the same now, we just need to mess with the exponents. We're just going to say, okay, 3x equals 2x minus 2. So x equals negative 2. And we can check that. You could put that in and check that. So if the bases are not the same, we want to make them the same by breaking it down into maybe a power of 2 or a power of 3 or a power of 4. After we've done that, we do need to apply our rules for exponents, whether it's adding them or multiplying, whatever those rules are, so that we can get the same base, and then all we have to do is look at the exponents. It's kind of like those rational functions where we multiply through by the LCD. Kind of gets rid of the fraction. We're just kind of getting rid of that base once we get them the same. Then we don't need to look at the base anymore. All right, you guys try this one. All right, so we don't have a common base, so we need to get one. So 3 is going to be the lowest base. You can't break 3 down. So we're going to keep 3 to the 2x. 9 we can write as 3 squared. All right, so we're going to break down 9 into 3 squared, so we get the same base. That's our goal here, get the same base. Now we're going to apply our rules of exponents. So we have 3 to the 2x equals 3. We're going to distribute that. 2 minus 6x. Now that the bases are the same, we can just set the exponents equal to each other. 2x equals 2 minus 6x. Can someone tell me what x equals? So 27 is 3 cubed. We have 3 to the 4th. 9 is 3 squared. This time we have 2 things going on. So here we're going to do the power. All right. Here we're going to do the power. So we have 3 to the 6x times 3 to the 4th equals 3 to the 6 minus, oh, I have an x and a p. Let's call that x. That should be x, sorry. 6x should be an x. So that's the power rule, but we also have this addition rule. Remember, when you multiply like bases, you add the exponents. So you have to be careful here. Here we're multiplying these two bases. So we're going to add those two values together. Now that all my bases are the same, okay, I can just look at the exponents. I'm going to have a 6x, but in between here I have a plus 4 equals 6 minus 6x. So you have two things going on. You have the power rule where you have to multiply, and here, since you're multiplying, you're going to add when you drop the bases and you make your equation, your little algebraic equation here. You have to remember, since I'm multiplying here, I'm going to have to add those. And then we have our nice little algebra 1 question. That's the good news, okay?